Hi, and welcome to the Algebra Review Second Note-Taking Guide. And as usual, the note-taking guides are going to start with a short paragraph followed by a couple questions that you need to answer. So if you have not already done so, please pause the video now, read the paragraph, and answer the questions in the lines below with 3 complete sentences, remembering that grammar, spelling, and punctuation do count. Start the video back up when you're ready. During this segment of our algebra review, we're going to talk about solving equations and inequalities. And I'm sure most of you have seen this before, but an equation is two equal expressions separated by, obviously, an equal sign. And when we think about solving them, we need to think of a balance scale, with one part of the expression on one side of the scale and the other portion, the other half, on the other side of the scale, or equal sign, and the pendulum or the fulcrum is the equal sign. So whatever we do to one side, we need to do to the other side of the equation. So if I add 7 pounds on one side of my equation, in order to keep that in balance, I need to add 7 pounds to the other side of that equation. And we're going to use two basic tools for solving equations. And in doing so, we're going to either add the same number or integer to both sides. Remembering we want to keep that balance scale or our equation in balance. The other thing we're going to use to solve equations is we're going to multiply the same integer to both sides, once again keeping our scale in balance. So the rules would be written: if we have an equation where A equals B, we need to have, if we add C to the left side of the equation, we need to add C to the right side of the equation. Same thing when we're multiplying. If again A equals B and we multiply A times C, we need to multiply B times C to keep them equal and in balance. So what does that mean? It means that if the same number is added to each side, the two sides are still going to be equal, just like adding 7 pounds to both sides of my scale. Once again, if the same number is subtracted from each side, once again, our sides are still equal. When we move on to multiplication, if the two sides are multiplied by the same non-zero number, then the two sides remain equal. And lastly, if we divide both sides by the same number, and remember we can't divide by 0, they remain equal as well. So your goal when you're solving an equation is to isolate or get that variable on the side all by itself. So we want to get the variable on one side and all the integers on the other. So our goal, in other words, is to get our equation written so we have variable equals some constant or number. And then one more rule that we use is to remove a term from one side of the equation. We're going to use the opposite operation. Sorry about that, guys. Helps if I check my spelling and don't just keep writing. So what does that mean, the opposite operation? The opposite operation from addition is subtraction. The opposite operation of multiplication is division. And obviously, the opposite of subtraction is addition, and the opposite of division is multiplication. Okay, let's try an example. We need to solve for y in the equation y minus 6 equals 9. So our goal is to isolate y or get it alone, so we need to eliminate that negative 6. So to do that, I'm going to have y minus 6 equals 9. The opposite of this subtraction is addition. So if I add it to one side, I add it to the other. So I have y, then I have 6 minus 6 is 0. They cancel out, equals 15. So we found the value for y that makes that statement true. The other thing I'd like you to do, though, is to check your answer. And to check an answer, you substitute your solution, in this case 15, into your original equation. So in y minus 6 equals 9, I'm going to substitute 15 in for y, and I get 9 equals 9. It's a simple check just to make sure you didn't make an error along the way. Okay, I'm going to do one more. In this case, we need to solve for y. In the equation, 13y plus 48 equals 8y minus 47. First thing that I notice when I look at this, I have variables on both sides of my equation. So I need to get my variables all on one side. In doing so, I'm going to subtract 8y from both sides and take care of the math. 13 minus 8, 5y, and then I just drop that 48 down, equals my 8y and negative 8y drop out, negative 47. So, looking at this, I want to isolate y. The next thing, I want to get rid of all the other terms. In this case, it's going to be the positive 48. So I'm going to subtract 48 from both sides. Sorry, guys. Minus 48, minus 48. And I have 5y, positive 48, negative 48 cancel, equal negative 47 plus negative 48 is negative 95 when I add those integers. And lastly, I need to get y by itself, and I've got this 5 hanging out front here. And when they're just next to each other like this, that means they're multiplied, and the opposite of multiplication is division. So I'm going to divide both sides by 5. Here they cancel. 5 divided by 5 is 1. I get rid of it. So I'm left with y equals negative 19. One last example. Sometimes we need to use the distributive property before we can combine like terms and get our variables isolated on one side. So looking at our next example, 3x minus 7 times the quantity 2x minus 13 equals 3 times the quantity negative 2x plus 9. The first thing I need to do is use that distributive property and multiply 7 and 3 through those parentheses. So I'm going to write 3x, and then I have negative 7 times 2, that's negative 14x, and then negative 7 times 13, a negative times a negative is a positive, and 7 times 13 is 91, and that equals 3 times negative 2 is negative 6x, and 3 times 9 is a positive 27. Now as I go along, I like to clean up my sides as I go and combine like terms. So I'm going to stop and I'm going to combine that 3x and negative 14x on this side, on the left side of the equation. So 3 plus negative 14 is negative 11x plus 91 equals negative 6x plus 27. And this is, at this point, very similar to our previous example. So we need to get our letters on one side and our numbers on the other. In this case, I think I'm going to take care and add a positive 6x to both sides of my equation. Negative 11 plus 6 is negative 5x plus 91. Negative 6x, positive 6x cancel out, so that equals 27. Next, I need to eliminate this positive 91, so I'm going to subtract 91 from both sides, and I'm left with negative 5x, positive 91, negative 91 cancel out. This equals negative 64. Now I need to take care of the 5, and I'm going to divide both sides by negative 5. And I am left with, as a solution, x equals, and you can leave it either as 64/5, knowing that a negative divided by a negative is a positive, or you could write this as a decimal, 12.8 if you like, or simplify the fraction. At this point, I'd like you to pause the video and try the next several equations on your own, and that will be, the solutions are going to follow in the next video segment. See you when you're ready.